We've got an integration question that goes into a differential equation. Let's deal with the integration to start with. We're given the substitution, asked to show the left-hand side becomes the right-hand side where k is a constant. So u is actually 4 minus h to a half. What I'm going to do is find du by dh, which becomes minus a half h to the minus a half. And that means dh by du will be minus 2 h to the half. So my integral now, there's a couple ways to think about it, but both are going to involve me writing 1 over u, and then you either write dh by du and sub in the dh by du, which is equal to minus 2 h to the half, or you make dh the subject. We actually will get the same result because you can see it here. This is exactly the same as this. So it's okay. Just two different ways of doing it, basically. I tend to go for this first one because it's a bit clearer that we're using the chain rule. Okay, the thing is, I need to integrate with respect to u, and at the moment I've got 1 over u times minus 2 root h du. I can't integrate this as it is. I need to get root h in terms of u, and I can do that by going back to my original substitution. Root h is then actually going to be 4 minus u. Okay, so that worked out pretty well. So I'm going to get the integral of minus 2, 4 minus u, all over u du, which will give me 2u minus 8 over u du, or in fact 2 minus 8 over u du. Okay, it's ready to integrate now. So I'm going to integrate it and get 2u minus 8 ln u plus c. But don't forget, u is actually equal to 4 minus root h. So I can just replace it. 4 minus root h minus 8 ln modulus 4 minus root h plus c. This will become 8 minus 2 root h minus 8 ln 4 minus root h plus c, which is very much like the answer. So I've got a minus 8 ln 4 minus root h sorted. My next term is minus 2 root h. It's just that it's then got a plus k. But that's precisely what c plus 8 is. Because c is an arbitrary constant, I might as well absorb it with the 8 and just call it something else. There's no need to have a plus 8 there. I could add 16 if I wanted to, then k would just be different or c would be different. So we can just write it in terms of a single constant like that. And there we go. That's our substitution to get the answer to this integral. Nice. So part B, well, it says, first of all, a team of scientists is studying a species of slow-growing tree. The rate of change of a tree in this species is modeled by this differential equation. Okay, there's a similar thing going on to the earlier parts, but there's a t in there as well. But in B, it just says, find according to the model, the range in heights of the trees in this species. Only 2 marks. We don't have to do a lot here. We've got to think about what the equation is actually saying. And what is going on is you've got to think about what happens when dh by dt would be 0. And in fact, this thing would be 0. So as dh, actually, to be honest, I should probably say as 4 minus root h approaches 0, dh by dt will approach 0. And this one is happening as root h is approaching 4. So as root h approaches 4, the derivative is going to approach 0. It's going to basically be, the gradient's going to be getting smaller and smaller. The height is going to be increasing by less and less each time. And this is going to happen as h approaches 16, as root h approaches 4, so h approaches 16. And that, in fact, is going to give us our range. So 0 is going to be less than or equal to h, which will be less than 16. You get away with a variety of answers here as long as you got the number 16 in there, really, and saying that h is going to be less than or equal to. You do get away with less than or equal to as well. The 0, I think, is useful just to show that it can be negative, but it's not actually essential. We could even write in words that the height can go up to 16. So just something along these lines is what we're looking for. Just going to clear a bit of space for the last part. Okay, we're told in the final part that one of these trees is 1 meter high when it's first planted. So that means t equals 0, h equals 1. And according to the model, calculate the time this tree would take to reach a height of 12 meters. So when h is 12, what would the time be? Giving your answer to three significant figures. Well, we have a differential equation here. We're trying to get h in terms of t. And you can't just integrate it because there's a function of h on the right. We need to use separation of variables. So the first thing to do is, in fact, to divide through by 4 minus root h. And this turns it into something somewhat familiar because we dealt with that integral in part A. And that then equals t to 0.25 over 20. You might also times through by 20. That's an option. I didn't. I just because we've dealt with this up here, I thought, you know what, I'm just gonna leave it exactly like that. And then we can one way to think about it is you can times through by dt and then just stick an integral sign around it. The other way is to argue a little bit more clearly and say, right, I'm going to integrate both sides with respect to t. It's just that this thing here becomes dh using the chain rule, and you get the same end result. So the left-hand side we know is minus 8 ln 4 minus root h minus 2 root h. Now, I don't normally put the constant on the left. I normally put it on the right, but I'll stick with it on the left. It's not really going to matter, but then you don't put it on the right as well. Okay, you just need it on one side because if you've got it on both sides, you can just combine them. And then over here, I've got add 1 to the power, so t to the 1.25, or I could write 5 over 4. And then I'm going to divide by that 1.25. So I'm going to do 1 divided by 20 divided by 1.25, which actually gives me 25. Right, now we've got an unknown k, but we've got when t is 0, h is 1. So I can just substitute in. I guess I could make, I'm not going to make h the subject or anything. I could times through by the 25. Do you know what? I think I'm just going to leave it like it is because we're only interested in a time when h is 12. It's fine having the divide by 25 there. So when t is 0, h is 1. That means that minus 8 ln 3 minus 2 plus k is going to equal 0. And therefore k is going to equal 2 plus 8 ln 3. Right, let's just write out the new result then. So therefore, I'll leave it exact for the moment. Okay, and now I'm going to sub in h is 12. So I'll get minus 8 ln 4 minus root 12 minus 2 root 12 plus 2 plus 8 ln 3 is equal to t, 5 over 4 over 25. Let's work out what that left-hand side is. root 12 is less than root 16. I don't actually need the modulus sign around it. Um, yeah, just if it was negative, just make it positive. Okay, just be really careful with all your brackets and everything. So we get 8.8511. T to the 5 over 4 is actually the fourth root of t raised to the power of 5. So I'm going to write it like that, and then take our answer and times it by 25. 221.279. Then to get t, I can just undo these operations. So I can take the fifth root of the number and then raise it to the power of 4. This actually turns out to be the same as doing raising it to the power of 4/5. All I'd say is be careful because sometimes you can't just swap it. Like people like to just swap it around and say, hey, it's going to become 4 over 5. But if you had something like 2 over 3, x to the 2/3 was equal to 10, then actually, if you do x equals 10 to the 3 over 2, you technically need a plus or minus there in the process of taking the square root. So I don't like to just say swap it around because it can lead to errors. I think it's healthier, a bit safer maybe, to just kind of write it like this. But it will actually be the same as raising it to the power of 4 over 5. I'm going to stick with what I'm saying though. So actually there's a little button here for the fifth root, and then I'm going to raise it all to the power of 4. Just need a bracket right at the start. Gives us 75.154, which to three significant figures gives us 75.2 years to achieve this height. Now, just want to say one of the way to do this question is as a definite integral. So we're saying we're integrating from 1 to 12 because that's the height change over time. And then from 0 to some capital T, don't keep it the same as little t. And then you put in the limits. It works in the same kind of way. You just end up subtracting and everything. You get exactly the same answer. I think I personally prefer to do it the way I did it because I made h a function of t. So it could be useful for then other situations if I wanted. Um, it's a more general formula, but I'm just saying that one's out there as well. So look, well done on this question. We've got this awkward substitution. Hopefully you're happy with that. This awkward part B to some extent. It's only a 2 marker, but just, you get these sorts of situations. You've got to look at the equation and figure out what's going on. And then to finish the differential equation. Well done.